Hi, I'm Mark Fletcher, and I'm Vice President of Public Safety Solutions at 911 Inform. The following is an audio version of my latest blog, Next Generation 911 and the Evolution of IoT. Although the first network-connected appliance was a Coke machine back in 1982 at Carnegie Mellon University's School of Computer Science in Pittsburgh, it didn't win first in the Internet of Things race as the World Wide Web had not yet been developed, and the connection was over a local computer network because, well, the Internet barely existed at that point. Therefore, it's generally accepted that after the Internet was real, along with what's now called the web, the first place prize for an IoT device goes to none other than a toaster, connected in 1990 by John Romke. Now, it's safe to say that the toast is finished and the existence of IoT is there, and its usefulness has been significantly improved, well beyond a whimsical display of ingenuity and home appliances. Well, just like that toaster, the legacy E911 network has also evolved after a long run of 50 years and is now dipping its digital toe, although cautiously, into the ocean of IoT, anxiously watching for the floodwaters to rise along with the value of this information. Training for the future. Monitoring networks and establishing workflows is a concept that's been a management practice for IT teams for some time now. For as long as networks have existed, they've used the network to monitor the network. In fact, the Simple Network Management Protocol, better known as SNMP, was designed and built specifically to deliver a standardized mechanism that was usable by devices to report error conditions to a centralized monitoring station, and with the addition of two-way control and intelligent workflow on one or both sides of that connection, voila, you've got IoT. Driving to a new paradigm. In 1996, General Motors North America Operations President Rick Wagner officially launched OnStar at the Chicago Auto Show. 11 months later, the service was available on select vehicles, and the world of IoT was well in motion with a custom solution running on a public network. Now, despite the initial slow connection speeds, they were sufficient for the payload of data that was being sent back to GM's OnStar Center after a triggering incident such as a crash, an airbag deployment, or an overturned vehicle. The information was reported back was collected from various sensors, all measuring safety devices and their activation, the number of occupants, and where they were seated, the important deceleration data known as delta V, or 60 to 0, which calculated the velocity of an impact. Now, correlating into a digital picture of the incident, all of these data points allowed GM to model the injuries and the vehicle condition, and that data provided an incredibly and statistically accurate picture to public safety and responders. In fact, I once heard an OnStar employee comment that their prediction rate was about 80% from a damage and personal injury perspective. Not too bad. Now, with this additional data, first responders and dispatch personnel could make more intelligent deployment decisions, getting the right resources on scene as quickly as possible without having to wait for an in-person on-scene evaluation. Lessons learned being extended. With building infrastructure being developed and fine-tuned in the physical environment and the mobile IoT market already in existence, covering the collection and transport of that data, now is the perfect time to merge technology streams and allow the connected smart building to emerge and flourish, providing valuable data during various incidents. Now, although new processes will need to be developed and put into place, the collection of the relevant data points should remain relatively identical to what's happening today. The bulk of the work to be done will remain in the use cases and user stories that'll define the information collection scenarios, and the appropriate requirements that those processes will demand will be put into place. Connected school building safety solutions. Now, there's no denying that a common problem that's occurring today is the scenario of protecting students in our nation's school systems. Almost weekly, reports on the news highlight incidents involving a rogue individual entering into a restricted environment and then unleashing terror on the occupants through the use of a weapon. Fortunately, technology is readily available that'll detect, alert, and help mitigate incidents as long as that information can be collected, analyzed, and provided to the proper individuals in an expedient manner. New innovative data collection capabilities. Video recognition. Most new cameras deployed today are of sufficient resolution and are IP enabled, allowing them to collect the required images and communicate them back to a central processing server for further analysis. Once there, images can be examined for facial recognition matches, weapons detection matches, and even license plate reader matches when monitoring a parking lot entrance. And this capability is one that is drastically improved in both price and functionality and can be effectively deployed in key areas where needed, many times on existing equipment. In an area considered a high threat area, millimeter wave technology, similar to those rotating scanners that you see at the airport, is able to detect anomalies under clothing or inside bags, and can do it at distances of more than 100 feet. So an event generated by one of these could lock down a building well before an undesirable visitor even approaches. In fact, if the individual was known to the facility through facial recognition and specifically banned from the property, an IoT camera at the parking lot entrance could have picked up his presence well before the individual even parked or exited their vehicle. ShotSpotter technology. While picking up gunfire does nothing to prevent a situation, having that gunfire data during an incident can provide responders with valuable information about the weapon types being used and where they've been used. This is valuable data that contributes to the overall situational awareness, allowing intelligent and educated decisions to be made by those with the experience and now the relevant data. Putting it all together. This is precisely the environment that we built the 911 Inform platform to operate in by ubiquitously collecting data and information being delivered from various sensors in an open ecosystem while using standard communications protocols, where our platform develops and renders a base level starting map for any situation and in nearly any environment. This primary command and control point provides a single pane of glass for the field responder that is web-based and available on any Chrome-enabled device. Additionally, it's a highly interactive remote control platform for door locks, video camera feeds, as well as control of any other IP subsystem that offers an open API interface. In fact, for critical applications requiring resiliency and redundancy, the connectivity back into public safety, as well as the core, could be supplied through a cellular connection that's free from physical infrastructure and powered by solar. This would make the solution completely standalone from any external utility infrastructure. Innovation. Gotta love how it can make the hardest problems just disappear. I'm Mark Fletcher. I'm Vice President of Public Safety Solutions at 911 Inform. You can follow me on Twitter at Fletch911. Check out all my blogs and podcasts, as well as my profiles on LinkedIn and Facebook. And if you'd like an in-person demo of this amazing technology, just reach out to 911 Inform at 911inform.com or give one of our sales specialists a call at 833-333-1911. This is Fletch. Thanks again for listening. Stay safe and have a great day.